Hello, boys, girls, dad, and others. There are others watching videos. Are they bored and they need to watch statistics videos? Must be good bedtime material. Okay, so I'm gonna make 4 videos in this series, and you've already seen the first one on the introduction to correlation. Today we're gonna talk about meaningfulness. So if we go back and we remember that correlation is equal to R. And that is the relationship between 2 variables. Remember, a perfect correlation is 1, and a perfect correlation is -1. One going uphill, as one variable gets larger, so does the other. One going downhill, or as one goes up, the other one goes down, an inverse relationship. Well, and we had varying degrees of it until we got to 0, where there was no relationship between the 2 variables. Today we're going to investigate something called the meaningfulness. I wonder if this is really a word in the dictionary. It is in statistics. Okay? And meaningfulness is very, very simple to calculate. Okay? It's simply R squared. And sometimes people say, well, what's R? Well, this is R. We've already calculated R. Okay, so you already have the correlation. Now all you're going to do is square that correlation. And that's all the math you need for this video. Now, to understand that, you need to put your thinking cap on a little bit. Okay, because this is a really important concept in statistics. So, meaningfulness is also referred to as the coefficient of determination. Has a couple of other names, but when you see it in the literature, it's usually written as meaningfulness. So when I get a correlation, let's just say I have a correlation equal to positive 0.8. Okay, you remember that looks something like this. Okay? So I have an x variable and a y variable. So let's go back to hours of studying and grade. So we would expect that the more you study, the higher your grade. It's not everything that goes into it, and that's why it doesn't account for all of the variation, right? So if I have an R of 0.8, if I square it, I get an R squared equal to 0.64. You can put that in your calculator, but that's what it is. 8 times 8 is 64, move the decimal place too. So I have a meaningfulness of 0.64. But what does that mean? Okay, so this is where it's really a great concept. And what that means is that 64% of the variance in the y variable in grade, as this, I'm going to underline it and I'm going to show you a trick later. In grade is accounted for by the variance in hours of study. Okay, so I'm going to underline this also, and this. So 64%, remember to get a percentage, we move the decimal place twice. 64% of the variance in grade is accounted for by the variance in hours of studying. So here's a good way to think of that. If this is your grade, and the green, hopefully it shows up, okay? The green is our hours of study. We'll just call it HOS. Okay, it kind of looks like my initials. Okay, POS. Okay. If this is the total variance, this is the total of all the people in my study and how many hours they study, and this is everybody's grade inside another bubble, we would expect them to overlap at about 64%. I know it isn't 64, but you know, I can't draw, so we just pretend, okay? So, it's the amount of variance in the grade, because not everybody that studies for 3 hours gets the exact same grade, right? Sometimes you study for 3 hours, and if you're like me learning Spanish, you can study for 3 hours and still get a 75, okay? Where someone else studies their Spanish, they go home and study their Spanish, and they get a 95 when they study for 3 hours, and I really resent them. Okay? So it's the same thing in every topic. The hours of study doesn't equal or predict, okay? But we're going to show how we can predict and how we can show variance. Okay? So whenever we have the meaningfulness, we have about how much variance is being accounted for. The rule of thumb with collecting data in with human studies anyway, and those are the studies I know best. The rule of thumb is it's pretty good if you account for about 50% of the variance. Okay? So 50% of the variance would mean I would have a correlation R approximately equal to 0.7, right? Because 0.7 squared equals 0.49. And 49, close enough to 50. I've said we're kind of lazy mathematicians. We just kind of, just about, okay? About 50% of the variance. If you can account for 50% of the variance with only collecting one other piece of data, then this works wonders, okay? All right, so that is meaningfulness in a nutshell. Let me preview the next video because, gosh, you just can't wait for it, right? Okay, so in the next video, I'm going to have the same clothes on. I'm just going to do a lot of short videos today. Okay, so in the next video, I'm going to put a line of best fit through my data. Okay? And I'm going to predict with X what my Y would be. Perfect? Okay, I'll see you in a few minutes. Bye.